Okay, so again, 6.6 is the last section of the unit. This is going to be 6.6 square root inverses. We are a little bit low on time, so I'm just going to show you how to do it, right? I'm not going to spend much time getting into the concept today. We just got to, here's how you do it, okay? So two types of questions here, okay? Two types of questions. First is going to be inverse graphs. Inverse graphs is the first type of question. Okay, so let's say I gave you the following. F of x equals 2 plus square root x minus 4. So this is a square root equation. We're going to graph it, and we're going to graph its inverse. All right, so I'm just going to show you the fastest way to do it today, okay? So we've got this equation. First thing we want to do is we're going to type it into Desmos. So we're going to type in 2 plus square root x minus 4. Then we're going to convert it to a table and get some good points, okay? So let's type it in. Okay, let me find the graph here. Okay, so if you find the graph, find the starting point. Okay, the starting point there starts at what x value? Okay, starts at the x value of 4. Okay, so we're going to convert it to a table and then start our table at that starting point x value. Okay, so hit the gear. So again, let's hit this gear button here, and then choose the table icon to convert it to a table. So convert to table. Now you'll see we have a bunch of undefineds. Why do we have a bunch of undefined? Where's our starting point? It's 4. None of these start at 4 yet, right? So I'm just going to come in here and start my table, delete, delete, start my table at my starting x value of 4. Okay. It'll automatically calculate the y value for you. So I started at 4, and then I'm just going to keep going down the table. 4, then x value of 5, 6, 7, 8, okay? And then keep going until you get at least 3 good points. Okay. So just convert the table, start at the starting point, x value, and then just continue the table until you get 3 good points, which we now have. Does anybody have any issues getting that, the table and finding some points using Desmos? Okay. So type it in, convert to table, use the table to start at the starting point, and then get 3 points. Let me go ahead and write those 3 points down. So the 3 good points that I got here, starting at my starting point, 4, 2, 5, 3, and then my next good point is 8, 4. Try to avoid doing these crazy decimals that you have to round. Okay, just try to get to the good points there, nice and easy points. Okay. So now I'm going to come underneath and I'm going to sketch. I'm going to put those points on here and sketch my graph. So let's sketch the graph using those 3 points. All right. So let's put these points on here. So 4, 2, 5, 3, and then 8, 4. Okay, so put those 3 points on there, those 3 nice easy points, and then just sketch your curve. Starts at the starting point and then kind of curves, the points kind of start to go off to the side like that. All right, so this is the graph of the given equation. Okay, I just used Desmos to get some points to sketch that graph. Here's the new thing. The new thing is finding the inverse graph. Okay, so to find the inverse graph, what you're going to do is you're going to take the points in this table. Okay, we're going to make a new table for our inverse. Okay, we're going to make a new table for our inverse graph. All you have to do to create an inverse table is take the points and switch x and y. So you're going to take the points in the original, switch the x and y values, and these will give you inverse points. So if I have the point 4, 2, switch them to make what? 2, 4. The point 5, 3 will switch to become 3, 5. 8, 4 will switch to become 4, 8. These are points on our inverse graph. So now all I have to do is, once I have some points for my inverse, is put them on the graph and then sketch this new graph. So 2, 4, 3, 5, and 4, 8. Now, again, just follow the natural curve of the points, right? So I've got my starting point, follow the natural curve of the points, which kind of goes up. Okay. I've seen students in the past, they think all graphs have to go to the side. So I've seen students in the past draw some really funky looking graphs where they'll start here and then get to this point and go, well, it has to go off to the side, so let me just go like that. Okay, just follow the natural curve of the points. Okay, all right. So we have graphed the original graph and we've graphed the inverse graph. Any questions about that? All right, so again, you just type the equation in, get 3 points, okay, graph it, switch the values for the inverse points, graph that. I plan to only do one of these, so if you have any questions about this, now's the time to ask. Because the next type of question is a little bit harder. Okay. All right, so that's the basic idea of inverse graphs. Okay. So the next type of question is going to be inverse equations. Inverse equations. These are a little bit more complicated. All right, so first the steps. The steps to make inverse equations. Step 1 is you're going to switch x and y. What I mean by this is the letters x and y will literally switch places. We'll see in a minute. Step 2, you're going to solve for y. There's a couple other minor things that I don't think are worth putting in the steps, so that's basically the steps. Okay? So let's look at an example. So example 1. Let's say I gave you the equation y equals square root x minus 2 plus 3. Okay, so step one is to switch x and y. What I mean by this is the letter y and the letter x will literally switch places. So instead of y equals square root x minus 2, this will become x equals square root y minus 2. So x equals square root y minus 2 and then plus 3. So the x and y will switch. Okay. Next is to solve for y, and this will look very similar to what we've been doing the last few days. To solve for y, I first will need to isolate this square root. So what's attached to that square root? The plus 3. So get rid of the plus 3 by subtracting it over. So minus the 3. On the left-hand side, we have x minus 3, which can't combine, so that's just x minus 3 equals square root y minus 2. Then we get rid of the square root by doing what? Square both sides. So now we square both sides. Here's the good news, okay? We don't actually need to simplify it very much. So on the left-hand side, I don't need to actually FOIL that out. I can just leave it as x minus 3 squared. I'm not actually solving this. I'm just rewriting the equation, okay? So I don't need to solve it. Just leave it as x minus 3 squared. Equals, on the right-hand side, the square would cancel the square root, and I have y minus 2. And then I can simply solve the y by adding this 2 over to this left-hand side, and I've got x minus 3 squared plus 2 is equal to y. I just added this 2 over to here. And we're done. That's the inverse equation. Okay. The last little piece that is not nearly as important, okay, but you should be aware of it for multiple choice answer choices. This is the inverse equation. The last thing we probably should do is label it as the inverse. So to label this as the inverse, you're going to write f to the negative 1 of x is equal to that equation, x minus 3 squared plus 2. This f to the negative 1 of x is just the label for inverse. The negative 1 isn't actually doing anything, it's just the label. So we just labeled it as an inverse, and that is our answer. I'm not super picky about putting it, but you need to be aware of it because multiple choice answer choices will all use it. So I don't want you to see it on a multiple choice question and be like, I don't know what that means. Okay? It's just the label for inverse. Okay? All right. Okay, let's do another one. Number 2. F of x equals x minus 2 squared plus 3. Okay. So now in this case, first off, don't let f of x throw you off. F of x, if you recall from Algebra 1, is just a fancy way of saying y, okay? Don't let it throw you off. F of x is just a fancy way of saying y. You learned that in Algebra 1. Okay? So now switch x and y. So x and y will switch places. So we get x equals y minus 2 squared plus 3. So now we're going to solve for y. So in this case, we're going to isolate this squared piece. Okay, instead of a square root, we have a square. So we're going to isolate the square. Attached to it is a plus 3. So how do I get rid of the plus 3? Subtract it over. So then I have x minus 3 equals y minus 2 squared. The only tricky part here, right, is slightly different. We have a square. So what do I do to get rid of a square? A square root. Square roots and squares are inverses or opposites. So if you have, in the previous example, we had a square root, so we got rid of it with a square. Here, we have a square, so we get rid of it with a square root. So now I square root both sides. So on the left-hand side, again, you don't need to simplify it. It's just square root x minus 3 equals, on the right-hand side, the square cancels the square root, and you have y minus 2. And then I just solve for y by just adding this 2 over. So I just add this 2 over to here, and I get square root x minus 3, and then plus 2 at the end is equal to y. Okay, so now we're going to solve, so now we're done. Okay, last thing we have to do is label this as an inverse. So we're going to label it as an inverse. So to do that, we're going to do f to the negative 1 of x equals this equation. Again, this f to the negative 1 of x is just the label for inverse. It doesn't do anything. It's just the label for it. And so that would be our answer. Okay. With the time that remains, I'm going to have y'all try 2 on your own, and that'll be it for today. So try these 2 on your own. So number 3, f of x equals negative 1 plus square root x plus 2. So try that one on your own. And then number 4, try f of x equals x plus 1 squared minus 5. Okay, so try those 2 on your own, and that'll be it for today.